This is a webinar, which we haven't had a webinar in a long time, and I know it's been a while, y'all. But when opportunities pop up from my network, I like to bring my network in and see if there's something interesting that they have to share with y'all. So today we have from Midnight, we have Lauren, Idris, and Jay here. And Idris is going to walk us through an introduction to blockchain. And this is all in service of another time that they're going to come through, which I'll announce later on. But this is like, hey, making sure, let's get basics on blockchain, make sure everyone knows the myths and the truths and all that kind of stuff. And then next time they're going to talk more about Midnight specifically. There'll be a little bit of that at the end as well. But today is mostly an introduction to blockchain. We are recording this, and so if you're watching this later, we appreciate you. Thanks for watching when you can, and we look forward to maybe seeing you at that next meeting we're going to have. Feel free to use the chat, Takir. Appreciate you being in there. Y'all know how this works. You know how to be the chat. Y'all are natives to this. And with that, I'm going to hand it over to Idris. And Idris, tell us, please, all about blockchain.
All right. Thank you very much. Hi, everyone. Thank you all for joining once again. Today, we'll be talking about blockchain, everything blockchain, what you need to know, and also how does that relate to like real world experience and some of the example use cases that you might have seen or probably not noticed that this is being powered by blockchain somehow. And I know there was a point in time we had like NFT trends, we have all of these things going on. But what exactly is the tech powering NFTs? And then how is everything unfolding like under the hood? You get to know like in this session today. So about me, my name is Idris Olubisi. You can find me on Twitter as Olanesoft. I'm really excited to be here once again. And who am I? I am a developer educator at Midnight Foundation. I started my coding journey and experience on a mobile phone during the university days, and I was able to at least learn tech the hard way to start with, and it's pretty exciting where the journey, how far I've come today, and that's why I'm so much interested in campus program and also like seeing individuals representing as a student, maybe new graduate, if you are still currently studying, trying to thrive and learn more about tech ecosystem. And primarily, I believe like tech should meet people where they are. And if you find opportunity, you should always try to harness that particular opportunity because you never can tell where it would become really, really handy in the future. So you already know more than you think. As a developer, you have probably worked with different tools and different ecosystems so far. One of them is Git. Git is very popular, a distributed system, and it has like immutable log of changes. And I'm very sure that sounds like really, really familiar because at some point you have probably used Git or build your own personal project or even like contribute to open source technology generally. And another part is APIs, right? Interfaces and interacting with remote system. You have either interact with one or currently using one. I'm sure like this meeting is powered by some sort of API under the hood. And also you have probably built one yourself, a backend system, Java, C#, any of these toolings that you're already familiar with. And then we then have like open source. Open source allowing you as an individual contributor to contribute to the project that you love, or probably even start one project yourself and then opening it up to the public for contribution, which then means that we then have like permissionless contribution from anybody in the world. And that's one of the things Midnight preaches, and I would let you also know how that connects to blockchain as a whole. But to sum it up, like all of these things I mentioned, the Git version control system, APIs, and also open source, blockchain borrows all from these ideas all put together. But how does that happen? Let me take a step back to talk about how things get started in the beginning. There was a time, I think between 1999 to 2004, we had a very static ecosystem, like static websites, where you might already be familiar. I think at the point we have a first version of Mozilla, we have some static websites that just gives you information. That era is kind of termed as Web 1, right? The whole idea of Web 1, Web 2, Web 3 probably did not exist at the time until we had like Web3. Then for you to understand how things have moved from the beginning, then we kind of tag like this experience like, oh, from 1999 to 2004 is Web1. And during this era, you have read-only pages where people just visit a particular website to read information. The admin on the back end just like upload those information and you can read. You can't interact, you can only read, you can only consume content. But then there's a need for interaction, and also I think the whole idea of being able to send mail out, like mail people, get feedback, interact with the platform, and that's where Web2 steps in. Now, this gives you the ability to not just read about content, but write. So write in this case is interactions. Platforms like GitHub, Twitter, YouTube, you can create a pull request, you can comment, you can create an account, you can create repository. Those are interactions that you can do out of the box, and including social platforms. Like the end of era for Web 1 is 2004, but Web 2 still exists today. And that's exactly what Web 3 is built upon, right? In Web 2, in the Web 2 ecosystem also, you can create content, right? Platform own the infrastructure and you own your data and own your data on your behalf, right? If you have any account today with any of the social media platform, yes, you created the account, you fill in your information, but you don't necessarily own the data on that particular platform, right? But they are giving you this platform, an interactive platform to connect with people, to be able to do whatever they are doing on that particular platform, depending on its use case. But the part where it concerns like data, because they are providing you the infra and probably the ecosystem, you as the one supplying like your own personal information to be a part of that platform. But those data, you don't own them outrightly. We've seen cases where at some point your accounts could get banned, at some point for some reason, for unknown reasons, most times you could just get kicked out of a particular handle, and then that's all about it. But what then Web3 offers when you combine the previous ecosystem for Web 1 and Web 2, where we then have like reading, writing, and owning. Like the keyword here is owning. So I'll give you a particular example, right? Today you can write on Medium, for example, and then you write your content, you paywall it, they get some percentage, and you also get some percent. I think the percentage is around 60%. I don't know, like recently, but it's like 40, very ridiculous amount because they provide the infra for you, they give you the network, and now they are charging you for that. So you don't really own the content there. You are just like interacting with this platform. But an alternative for Medium in Web3 is Mirror. If you've heard about Mirror.xyz, Mirror does exactly the same thing, but the interesting thing is that there is no intermediary for Medium. So if you write a post, right, you can set your wallet address or your address to receive any fund for people to mint that particular post or like copy that post or like the post, depending on how someone wants to sponsor or fund you with the project, right? So that's exactly what Web3 is solving differently from Web2, comparing Medium and Mirrored XYZ in this example. So to like summarize it is that no single company can control the backend. And I would explain on that later on in this session. And you interact with decentralized network. I'll also talk about that later, what decentralized network means, and also how you can be a part of that network. But the core concept here is that the transition from the reading ecosystem, where you just consume content in Web 1, to being able to interact with those content, and now specifically thinking about ownership. How do you then own your data? How do you not just keep throwing data out there to a particular entity that can just reuse your data, make money off your data without your knowledge or without your consent or permissions? So to give you like the pictorial view of what it looks like, in summary, we have the Web 1, where it's just like an encyclopedia where everyone sees content and consume. And then we have Web 2, where we have like social media platforms. And then Web 3, you might have seen some of these images before. We have Ethereum, we have like a couple of them, MetaMask, Zerion, like a lot of them nowadays in the Web3 ecosystem. But obviously, like we're still using Web2 infra almost every day, and that's like way everywhere. Your social media app, the app that we're currently using right now. Some of the toolings that we have is built on the Web2 infra, and then we've also seen like rise and adoption from all of these Web2 ecosystem adopting what Web3 can offer. Of course, we have the payment rails, we have a lot of them, which I'll also be talking about in later in the session. But now let's talk about blockchain itself. Now that we've understood like the transition from how everything started, the web evolution to where we are today. What exactly is blockchain? To keep it simple, blockchain is a shared database where every entry on that particular database is represented as a transaction and is grouped into blocks. So what this means is that you can have like 100 transaction, and that transaction can be grouped into a particular block. And then let's say we have that is one, and then we have like 3 to 4, 5 of that. That means we can have like 3 to 4, 5 blocks, right? It can go as far as 100, 200, 300, and that becomes like blocks of chain, right? We have thousands of, depending on the number of transactions per block, and then connecting that block together, chaining it together means block of chains, right? And that's not all. Each block is then cryptographically linked to the previous one and then forming a chain. So this, to simply explain this, is that every block is somehow interconnected. But how are they interconnected? It is binded by a cryptography, hashing, and encryption to make sure that every block produced after the genesis block, which is like the first block that is created, is somehow linked together, even, which means that the first block is somehow linked to the thousandth block or the millionth block, right? Where you have like, so no matter how much blocks you have, there's some sort of interconnection that can link back to the root, which is where everything started. And then the interesting part of what blockchain does is today also is there's a copy of the chain that lives on many computer. So if you think about it, how do you handle like blocks of chains and then cryptography binding them together? There's something running somewhere, and that is refers to as nodes. But let me just simplify it like computer, like sitting somewhere. And then what that means is that somebody, if I am in the US, I can join a particular network. Someone from India can also join that network. We all have computers, and then the computer now is serving as a node that we can all contribute to that particular network. So irrespective of where you are in the world, all you need is internet access and be able to connect to that particular network. And the final piece is once something is written, it can't be altered, right? So that's also one good thing about like what blockchain does out of the box is immutability, right? You can't change things on chain. So a practical example here is, let's say you want to build a website for somebody, or you want to build an web application, and then you have an oral agreement. The person can come back tomorrow and tell you, hey, I don't think I want to pay you maybe $200 as agreed. I just want to pay you $100. And you'd be like, that was not our agreement. But if you're like, oh yeah, the market is bad. I don't think I'm really interested, excuses like that. And you can't really do anything per se. You have to let go and then move on to the next thing. But then if there's some sort of binding on with smart contract, which I'll also be talking about, and that smart contract get deployed on the blockchain, where you could have like your agreement written as a code and then deploy on the blockchain. So what that means is that once you have agreed orally or verbally with your client, you put it into written, and that is deployed on the chain as a code. And what that means is that the person must have connected his or her wallet, and you also connect your wallet. So at the point of, you can then schedule like after each milestone, these amounts to be sent to the other party. So if I'm the website developer and the milestone to complete is, let's say, 3 milestones for $200, right? So for every milestone, 33%, 33.33% needs to go out to my bank account. Once I meet that milestone, that automation could then happen. So, which means that the other end cannot come back and say, hey, I don't think I want to pay you this amount anymore. I just decide I'm not going forward with this project or doing all of this. So you can like remove the reliance on, changing promises, fake promises, or like trusting the trust side of things is not tied to somebody to believe like, oh, I'm going to pay you at this point in time, and then I get to pay you. So these are some of the key things around blockchain and what blockchain does today. To give you a particular example of connecting what that looks like in real life is see blockchain like a Google Doc where everybody can read information, but nobody can edit the Google Docs. And then there's no single person that can shut the doc down. Let's say somebody just feel like, oh, okay, I don't want anybody else to have access to this doc. Just put it in that way where everybody contributes, everybody can see things, no one can edit retroactively, and no single point of failure or single point of shutdown. That's just simply what it means and what blockchain is all about. But then the important piece is, why should you care as a developer? When I first learned about the blockchain, I was so much concerned about what can I do as a developer? How can I contribute my own skill set as a developer? And there are a few options, right? Because I already have experience with front end and back end. So I went straight to the tech side of things, because now me as a developer, I want to be able to build application that people can then use, leveraging the blockchain, right? So why should you care as a developer? If you have already, maybe you're familiar with front end or back end or database already, like traditional applications, you control everything and you can host it on one company, right? But then when it's blockchain app, you can write the front end and the smart contract plus the blockchain. So the logic and data live on a decentralized network. So what the system is replacing here is completely replacing the database side of things, right? I know we have seen like different type of application where you have like front end and back end. For blockchain, you still have that idea of front end and back end, but back end in this case could then be like just blockchain alone, unless you have an hybrid system that also then have like its own backend that now interacts with the blockchain. Then that hybrid system is now going to comprises of the front end, the back end, and the blockchain. But if you are just going to interact with the blockchain directly, then it means that it's just the front end and then the blockchain. So the logic, your data, network, your finance side of things, everything lives on the blockchain, and that is not controlled by anybody. So this is why you should care as a developer, because it gives you opportunity to use your existing skill sets and then build on top of the blockchain while you don't have anything to lose, doing all of these things. But then also using blockchain gives you a lot more when you are building as a developer. There's no single point of failure because it's a decentralized network of, system of nodes across the globe. And also users don't have to trust you. All they need to do is to just trust the code, right? You put in effort to write the contract and then deploy the code, and they don't have to trust the developer that is building the application. Then the interesting part is also the backend is open and auditable, and it runs exactly as written. So if you have any implementation, just like the example of you building a web application for a particular client, if it is written like the payment is going to be paid by milestone, it is going to run as it is after deploying to mainnet or to productions, right? So these are some of the things you should know at the back of your mind. Like if you are a developer and you want to build leveraging the blockchain technology, these are some things you should look out for. But connecting it to you as a GitHub, campus expert, you already championing like the open source ecosystem and transparency. So this is not new. So blockchain takes that philosophy and applies to infrastructure. So which means that everything is auditable. You can check things out Today, you can go to any block explorer, see what people are doing. In fact, you can paste in an address, see the asset on that address, see what the address is doing. Like everything is quite on-chain. But then there are also a few components that makes the whole idea of blockchain. Remember, I talked about smart contracts, I talked about some other things along the line. But what are some key components that you should know if you are new to blockchain or if you have started building on blockchain already? There are a few of them. We have the block here. I'll try to compare with like real world example that you might be familiar with already. So we have the block, which is a batch of transactions that I mentioned earlier, where you have like different transaction inside a particular block. And equating it to something you might be familiar with is like a Git commit that is bundled, that kind of bundles like several changes. You know, a particular commit could have like thousands of changes, right, within a particular app. So that's exactly how block is when it comes to like the blockchain ecosystem and how it serves as a component within the blockchain. So now that's block. Now let's talk about chain. So now we have block that works like a Git commit. Now blocks link in sequence where we have like cryptography hashes. And what that means is that changing one block breaks the chain. It's just like you force pushing a rebase that invalidates every downstream commit. So if you are familiar with like rebasing and also trying to force push a particular rebase, it means that you are automatically just invalidating the downstream of every commit on that particular work tree with Git. So that's exactly what change looks like and how that is kind of sequenced with an existing blocks within the network. And this is binded by a cryptographic hashing because of the math, because of the encryption, and because of the mathematical algorithm that is needed to make sure that the system is secure and also interconnected for every use case. Another component is node. I mentioned this earlier on, just like a computer running on the blockchain software. So think of it as a peer in a P2P network where each holding a full copy of the repo. So let's say, when you fork a particular GitHub repo right now, that's a copy of that particular repo that you're holding. So that's the way the node also works, right? So if there's any new changes in the system, you in the US get a copy of that change and somebody else in India also get a copy. So even if somebody in Germany, something happens to its node, everybody else have a copy of the current state of the network. So the network will never go down in as much all of these nodes and all of this ecosystem are interconnected, right? So that's exactly how it works if you compare it to like what we do today, where you can fork a GitHub, repo. Now, let's talk about the consensus mechanism, right? These are like terms. These are part of like the blockchain component that you need to know. Ordinarily, we are talking about this because we want to know the component, right? If you're interacting with the blockchain, you don't have to deal with all of this. Oh, I need to know this, I need to know that. A single transaction gets submitted and you get like an acknowledgement or a receipt that it has been submitted and you're good to go. But in this case, we need to talk about like what makes blockchain itself and what are some of the key components. So another one here is consensus mechanism, right? Because if you look at it, like everybody have nodes across the globe, worldwide. How do they agree on something? Like, I don't know this person, and this person has like a computer somewhere, and this person also have it somewhere. How do we then agree on, okay, this is time for us to add another block, or if we have 100 transactions, that should complete a block. Another block should be created. How do we agree on all of those rules? That is where consensus mechanism comes in, right? Because now we need to create a strategy that every node would adhere to, right? Irrespective of where you are in the world, right? So for an example here is that how node agrees on the next block, for example. So it's the merge strategy. So if we create a merge strategy that after every 100 transaction or after every particular condition, we should create a new block. Everybody gets that information. All the nodes agree to that particular information, and it remains like that forever until there's also another consensus mechanism upgrade that then needs to change. But if it doesn't change, that rule is going to cut across everybody's node worldwide. Then this is where the code side comes in as a developer, right? There's the network side of things, there's the node, but how can I deploy my code? How can I build an application and then deploy it on the network? What's the connectivity between me deploying and interacting? So this is where smart contract comes in. So smart contract is just an agreement written in code. So code deployed on blockchain that runs automatically when conditions are met. Back to our example for building a website for $200. When the condition for milestone 1 is completed, 33% of that payment goes out immediately to the developer. When another milestone is met, also same thing happens. So this is all those conditions. This is where you write it. If you are familiar with maybe front end and serverless ecosystem, it's just like a serverless function. But instead of like AWS or Netlify or any of the hosting service that you are using, instead of them owning it, the network itself owns it, right? So the network I'm talking about is the group of nodes that are interconnected together globally. Now, I think the last piece here is because if you look at like smart contract, now I've deployed the code. How can I then interact with the code? Right. Interacting with the code means that I need something as an identity for the blockchain to know that I am the one, right? So if I'm connecting my wallet, that is my identity on the blockchain. So we have a public key and a private key. Private key remains with me, and the public key is what every other person sees, right? So a real world example to connect this is if you're familiar with SSH key, but for signing transaction instead of git commit, right? If you create like an SSH key and remote it to your system, you can see you have access to do things directly, remotely from your system. But now think of it like you want to use that same analogy to sign transaction instead of the regular git commit that you have. So that's what wallet under the hood means to you as an identity on the chain. And I think we've talked about this before, the immutability side of things. That once your data is on chain, it stays there forever. Nothing like Git rebase or dropping table the way you would do in traditional database. It's permanent forever, and it's immutable. Everyone sees the changes and it remains like that. But then let me quickly touch on real world use cases that you can do with blockchain today. Finance and payments is one of the biggest part of the blockchain as a whole. It is natively built in for it. Today, if you are building a system, you build your front end, you build your back end, database, all of those things, and your application wants to start receiving payments, or maybe you want your users to be able to deposit funds, buy things, then you need to now integrate an external party, which is like a third party like Stripe, all of this payment gateway for your application to start receiving payment. But for blockchain, finance system is natively built in by default. So you deploying your application on the blockchain, you have access to the finance side of the blockchain, and you can interact with it from day one. We also have the supply chain and logistics that could also be on chain and be tracked on chain. We then have the healthcare system. We know how messed up medical records are today, and also how hard it is for you to move your record from one place. There's so many manual work in the process. Blockchain could also be used to like for data immutability, to make sure that we can keep track of records accordingly, and also accessibility is also a big role here, because once you have internet and you have network, you can get access to all of this data out of the box. Another one is the digital identity and credentials. If you're familiar with W3 school certification program, right, you will notice they use something called DID, which is like decentralized identity. Maybe you might have not noticed it, but if you look at the way they generate their own certification ID, it's quite different from every other ID idea. What they are using under the hood is some sort of encryption, like a decentralized identity on for credentials in particular. So those are also like use case for blockchain. Then we have the real estate world, tokenization assets. You might have heard about real world asset tokens and all of those things, right? And nowadays we have the AI plus blockchain, right? Agentic solution, building your application, connecting it. You can build your application to trade, to buy and sell, to do all of this cool stuff and just directly connect it on chain. But then to then give you what it looks like, so many companies are adopting, the whole idea of stablecoin right now, nowadays, right? Stripe started accepting stablecoin, same as Mastercard, some of these card gateways, and Walmart. USDC became like the strongest like stablecoin assets that you could have, and also integrate to your day-to-day activity. So these are just a very few example of some really, really like mainstream company that are already adopting the whole idea of blockchain and also stable coins at large. These are like people that you're familiar with already, and you must have been seeing like some of these updates to adopt. And these are like real world use case where people can just ordinarily just connect. If you already have a Stripe account, you can enable it and start receiving payments in crypto. So, but there's one problem that most blockchain don't solve today. And it's interesting because you might not notice until you start experiencing it, right? And what exactly is that? Is every transaction is on chain, is open to everybody. Every balance is on chain, is open to everybody. Every interaction, if you send money to me, everybody gets to see it if they know my wallet address. That's great for transparency, but it's very terrible for some other things. So what are those other things that is terrible for? Healthcare records. Very terrible for healthcare records. You don't want everybody to know your healthcare status globally, all because you want to adopt the blockchain. Your financial data, there are some financial data that you don't want to publicize, right? Imagine JP Morgan, the way they do their transaction, and imagine them all publicly putting everybody's finance data on chain. It does not make sense to them, and they will never do such a thing, right? It remains hidden. And then now also talk about the identity verification. It's very hard because you as a user, you can create multiple wallet addresses, right? How do you identify who is who? How do I know you that you own this and you actually and truly own it? So whenever I see that particular identity, I know it's you. How do I verify that? That's also another problem. Any app where users deserve privacy. Nowadays, if you log into a website in the Europe, you see for you to accept a particular cookie, all of these things are because of your privacy. They want you to consent to using some of your some of your data that you have exposed to the application. But any application that deserves like privacy for payments, for all of these things, this is a problem that blockchain do not solve out of the box. Because now the question is, what if you could prove something is true without revealing the underlying data? I want to prove that this thing that I have is genuine and it's true, but I don't want to show you the underlying data. I don't want you to see everything, but I want to prove it to you, and I want you and I to accept that yes, this is true. How do I achieve that? That is where zero knowledge proofs comes in. If you are hearing this for the first time, zero knowledge proof lets you prove things without exposing the details behind it. So an example is if you are over 18, for example, you want to enter a particular site, or you are going to an event and they want to be sure that you are over 18. How do you prove to them that you are over 18 without showing your ID or even your name? What happens under the hood? How does how do you present it, and how would the maybe anybody trying to validate that this is true even after your presentation? This is where zero knowledge proof helps you to um generate your own proof, and from both end, which is the prover and the verifier, can both agree that yes, this is actually correct and you are good to go, or you are good to enter the particular party or an event that you want to enter because you are over 18. But it doesn't stop it. Like that's not the only thing, because now that is for an end user. For developers, you can verify a function output is correct without seeing the input. But then you might be wondering, what exactly powers this? It is the mathematics behind it, right? I don't want to go into like some technical details about it, but an overview is to think about it like something that you and I agree on to verify things. So for a developer, you can verify a function output without seeing the input. So which means that you can write your code in such a way that you can clearly know what would be the output, irrespective of whatever the input is. So zero knowledge would then have like two different types, the interactive and the non-interactive. So the interactive here is that you verify, you interact with the system returns back with its details, and you continue to do that back and forth. The non-interactive is the one that blockchain uses today. So for any privacy concern or like zero knowledge proofs blockchain, what they use is non-interactive because interactive is quite expensive. So what that means is that they would have an algorithm set, and once that algorithm is set, all you need to do is that we both need to agree that that algorithm is set, and then we can then share data over that. So me as a prover, I can prove whatever I want to prove. You as the verifier on the other end, you can also verify that, yes, this is correct without seeing the underlying data. So this is the foundation of privacy preserving blockchain, and this is an example of what Midnight is built on. Midnight is also a blockchain, a network on its own, but for privacy preserving application. So to keep it simple, Midnight is a privacy focused blockchain that gives developer a selective disclosure. So you choose what you want to go public and what you want to stay private. So I gave an example of JP Morgan not being able to publish their financial data on chain because those are things that they need to keep secret, right? How do they go mainstream, or how do they adopt blockchain if there's no privacy? That's what Midnight offers. Midnight gives them the ability to selectively disclose some of this data that they want publicly, and then keep every other thing private while still leveraging the functionality or the benefit of the blockchain, right? So to keep things simple, we've also tried, because we know like everyone, the AI ecosystem, everyone would like to get started, you would like to learn more about the whole idea of blockchain and also Midnight. So we have an MCP package that you can install right out of the box. If you have your Copilot, you can directly just install the MCP package there. If you have your any other um, I personally use VS Code and Copilot, so I have this integrated. So if you are using any other VS, like any other ID, then yeah, it's also like the same process. But like VS Code just makes it make sense for me, and very easy to also work with Git, work with GitHub and all of those things out of the box. And also, if you are completely new to the zero knowledge proofs ecosystem, we have the Academy that is free that you can check out, academy at midnight.network to get started. And you can just learn on your own at your own pace, and you get certification for it for free, to learn more about blockchain, learn more about privacy, learn more about zero knowledge proof that I just talked about, and you'll be good to go. And then finally, the docs, which is the home for every other thing you need. Yeah, so that brings me to the end of today's presentation. I hope you all um, enjoy this whole session entirely. This is the QR code you're seeing on the screen. It's just like a 1 minute survey. Let me know what you think about this presentation, how if you have learned anything or not, and also I'm opening the floor if you have any question, and I'll be happy to answer them.
Yeah, as y'all start thinking of your questions, I'm going to say thank you very much, Idris, for being here. I appreciate your time today and your insight and your learning. This helped actually me understand crypto and blockchain and Web3 just a little bit better, and it also reinforced some things that I had heard before too. Very